Hello friends, welcome to Bhavesh Sirki online class.
Hello friends, I am writing an equation on the board, x plus 3 equal to 5, and if I ask you to solve this, you will say, sir, it's very simple. X is equal to 5 minus 3, x is equal to 2, this is your answer. You are absolutely right if you think in these lines. These are called as linear equations in one variable. Why they are called as the linear equations? Because its degree is 1. Degree means the power of the variable is 1. As well as we are using only one variable. So these are linear equation in one variables. It may happen if the same equation is written in a different form. What I mean to say is, if I write down x plus 3 is greater than 5, then this is no longer an equation because there is no equality sign. Instead of equality there is a greater than sign. So such kind of equations are called as I can't call them as equations. They are called as inequations. Why they are called as inequations? Because there is no equal to sign over here. So if somebody asks me to solve this particular inequation, then it will be x is equal to 5 minus 3. Therefore x will be greater than 2. That means value of x can be anything, but anything more than 2. It may be 2.1, 2.2 or whatever it may be, more than 2. So we are going to see today inequations. Fine, and that also linear inequations. And how many variable in grade 10 we are going to use? Only one variable. So our today's topic is linear inequations, and that also in one variable. We have to understand quite a few parts in this. First thing, we should know the rules of solving the inequations. We are supposed to see representing the answer, and when I say representing the answer, it has to be understood very well because it is divided into two ways. One way, as I told you, we are going to understand few things. One is rules of solving equations. Second, representing the answer. It is represented in two different ways. One, in the set form, and second, on a number line. Now rules for solving or rules of solving are quite a few, same as what we did in the equations. I just would like to explain here. It was x plus 3 equal to 5. You have changed addition operation and you have taken it on the other side, so it has become subtraction. So changing the side will change the operation. Here addition becomes subtraction. Suppose you are given an inequation this way, y minus 4 is greater than 9. Therefore, if I take positive 4 on other side, so 9 plus 4, negative 4 on other side, it will become positive 4. So y will be greater than 13. So these are the rules of addition and subtraction, which are same as what we did in equations in one variable, or whatever equations we did, the addition and subtraction rules remains the same. Now what we are going to understand is multiplication and division rules, which are very important to understand. We shall move to rules of multiplication and division. For the rule of multiplication, I have taken two examples. Y over 5 is greater than 4 and x over negative 3 is less than 7. Before I explain you these rules, let me take this example. So for example, I am writing 15 is greater than 12. I am multiplying both sides by this particular inequation. I am multiplying both sides by positive 2. So 15 2s are 30, 12 2s are 24. So 30 and 24, if I compare, it will be greater than sign. Now why did I take this example? I will take one more example. Say for example 15 is greater than 12. Again same thing, but this time instead of multiplying by positive number, I'm multiplying it by negative number. So 15, of course both sides, 15 into negative 2 is negative 30, 12 into negative 2 is negative 24. Now you see what happens over here. If you observe this very carefully, what happens over here? Negative 30 is smaller than negative 24. And my dear friends, many a times you write down this incorrectly. The red part is incorrect. So many a times you write down this. So what is the key point over here? If you are multiplying both sides by a negative number, then inequality sign reverses. If it is greater than, it becomes less than. Let us come back and understand this. Here, if I take multiply 5 on the other side, what will happen? Y is greater than 4 into 5. So therefore, Y will be greater than 20. Over here, X, and I'm multiplying negative 3 on the other side. Then as I told you, this greater than will become, less than will become greater than, and your final answer is X is greater than negative 21. My dear friends, this is a rule of multiplication. If you multiply by a positive number, inequality sign does not change. If you multiply by negative number, inequality sign changes. Let's see about division also. What happens in the case of division? Say for example, I am having 3x is less than 12. I am dividing both sides by 3. So x 12 over 3, and this will remain less than x is less than 4. So when you are dividing by a positive number, the inequality sign does not reverse, it remains the same. But suppose I am having something like this, negative 2p is greater than 12, and if I divide both sides by negative 2, what happens here is the same thing. Inequality will change because you are dividing both sides by negative number, so value of p will be less than negative 2. So my dear friends, rules of multiplication and division, you have to be very careful whenever you are dividing by negative number or whenever you are multiplying by negative number. We shall understand the next rule of inequations whenever you are solving that inequations. Say for example 5 is greater than 2. I am taking multiplicative inverse of both sides. So this will become 1 over 5, and here it will become 1 upon 2. And my dear friends, if you calculate 1 upon 5, then value of 1 upon 5 will be 0.2, and value of 1 upon 2 is 0.5. If you observe this carefully, what happens here? It was greater than sign, and when I took the multiplicative inverse, the inequality has changed. So what I mean to say is, whenever you take multiplicative inverse of both sides of an inequation, then inequality sign reverses. So this inequation is written as 1 over x plus 5 is greater than 1 over 7. I am taking multiplicative inverse of both x plus 5 and here 7. Here it was greater than sign, it will change it to less than sign. And of course later on we are just following the rules of subtraction. So x will be less than 2. This is the answer for this particular thing. The important thing, if you take multiplicative inverse, then inequality sign reverses. Remember that. Next rule what we are going to understand is something very interesting. Say for example, I am having 12 greater than 8, and if I change the sign of both the numbers, what will happen? Here is negative 12 and here is negative 8. And if you observe it carefully, negative 12 is smaller than negative 8. What I mean to say is, if you change the signs of each term on both sides of the inequation, then inequation relation will change from greater than to smaller than, or smaller than to greater than. In this case, if I write down negative x minus 5 and here negative 7, if I am changing the sign of each one, then this less than has to be written down as greater than. One more example, suppose I am having negative y plus 7 is greater than 8, and if I want to change the sign of negative y, I cannot change the sign of negative y. I'm changing sign of each number. So negative y becomes positive y, positive 7 becomes negative 7, 8 becomes negative 8, and at the same time greater than sign will change to less than sign. Second part of the chapter, representing answer in a different forms. Two forms it can be represented. One is set form, another is number line form. Right now we are learning set form. Say for example, if I write down 0 is smaller than x is smaller than 3, right? Then x will take the value anything between 0 to 3, more than 0 but less than 3. But suppose I write down x belongs to natural number, my dear friends, then what will be the answer of this particular question? In the set form it will be written down as 0 less than x. That means x is greater than 0, that is 1. It can be 2, it cannot be 3. I have written down only two numbers, 1 and 2. Why I have written down as two numbers 1 and 2? Because x has to be a natural number. Say for example, I am taking one more example over here. This was first example. Now second example, negative 1 is smaller than y, or rather negative 3 is smaller than y, and y is smaller than 4. Here y belongs to natural number. Then what will be the answer? Remember, it is negative 3, y is greater than negative 3. But negative 3 is a bigger number, negative 2, negative 1, 0, 1, 2, 3, likewise. But here you can see the replacement set, means the set from which I have to select the number is natural number. So I cannot write down, ideally this would be the answer, ideally. Please understand this very well. Ideally this would be the answer. But y being a natural number, I cannot take these three numbers because these three numbers are not natural numbers. So your set, answer set will be 1, 2, 3. Suppose with the same equation, if y belongs to whole numbers, w stands for whole numbers, then this particular answer would change to 0, 1, 2, 3. Y belongs to integers. Remember friends, integers is also represented by z. Most of the time it is represented by capital I, sometimes it is represented by z, so you have to be very careful over here. Then how can I write down this solution? I have to write down this solution as y is greater than negative 3. That means it can have a value of negative 2, negative 1, 0, 1, 2, 3. So last part, we have studied real numbers also. Y belongs to real numbers. Then how to represent this set? Remember, whenever the set is in the form of real number, you cannot list the elements. Remember, I am repeating, if it is answer is real number, you cannot represent in the form of a list form. This is list form. You should know set can be written down in two ways. Set form, that is rule form, as well as the listing form. 1, 2, 3 examples are listing form. Now rule form, how will I write down? Here variable is y such that y belongs to real number, and remember, in few of the textbook or few of the reference book, and will be written by using this symbol. Few books represent and by this symbol also, so you have to be careful about that also. Y such that, two dots means such that y belongs to real number, and you have to just write the range. Negative 3 is less than y is less than negative 4. I would like to repeat, these are called as replacement sets. Replacement set means answer has to be selected from this particular set. Your answer may be something natural number, infinite natural numbers are there, but I have restricted myself up to 3 because here it says less than 4. So these are called as a replacement set. These are called as a solution set. Whatever is extreme right are solution set. I would like to remind you, whenever answer is in real number and you are representing in a set form, it is always the rule form. You cannot list the real numbers in a set. Dear friends, now we will understand how to represent answer or the solution on a number line. I am taking one example. Negative 4 is less than or equal to 4 is less than 5. Now in this case I am taking x as a natural number. Whenever you have to represent in the form of a number line, I would suggest you strongly that first you write it down in the set form. Now what will be the set form of this particular inequation, value of x in a set form, list form? I cannot take negative values because neither negative values nor 0 because x is a natural number. So which are the numbers which can be represented? 1, 2, 3, 4, 5. Now as I told you, we are supposed to represent this on a number line. You know a number line? 0, 1, 2, 3, 4 and 5. My dear friends, this I made an error. I am correcting it. It is less than 5, so it will be 1, 2, 3, 4. Now the answer is in the form of natural numbers and I have 4 members in that set. So representation of this will be a dark dot over here, dark dot over here, dark dot over here, dark dot over here. Remember, there should be minimum one number additional on the right side of the last number as well as the left side of the first number. So your first number was 1, left to that one number is, I have not marked this, remember, because it is not a part of a solution. So you have to know this very well, that whatever numbers you are representing, and this is number line based on only natural numbers. So 1, 2, 3, 4, I have darkened those numbers. One number prior to the first number, one number after the last number should be shown on a number line. Suppose the same thing I have to represent using integers, or rather first we'll take whole numbers. Then this answer will change to 0, 1, 2, 3, 4. Now how to represent this on a number line? Obviously I'll write it down here: 0, 1, 2, 3, 4. Last number here is 4. I will write down one more number. Here first number is 0. I'll write down a number prior to it. Now what will happen here? What will happen here? Which numbers to be highlighted? 0, 1, 2, 3, 4, 5. I don't have to highlight because last number is 4, but first number and last number. Highlighting is with a dark dot. Fine. And remember, dark dot should be visible to the paper corrector. Some of you make the dark dot like this. You know, this is your dark dot. Yeah, which is not visible. Dark dot means it should be almost a small circle and fill up with a pencil. And generally number line, all the time number lines you'll be drawing with the help of a pencil. Very important instruction: with pencil only you will draw the number lines. X belongs to integers. In this case, X belongs to integers. What will happen over here? What will be your answer set? Answer set will be -4. If I am including -4, observe this is less than or equal to. If it would have been only less than 4, then I cannot include -4. But here inequation says that -4 is less than or equal to. So -4, -3, -2, -1, 0, 1, 2, 3, 4. So number line, I am beginning with here -4 is the first number. So here my first number will be -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, and last number is 4. So one additional number, 5. Now, which numbers to be highlighted? Whichever are there in the set are to be highlighted. -4, -3, -2, -1, 0, 1, 2, 3, 4. I don't have to highlight one. Remember, whenever you are representing on a number line, one number preceding and one number succeeding should be written down without fail. Okay, dear friends, we shall understand how to represent the solution on a number line when the answer is in the form of a real number. What method I am going to use is called as a Lollipop method, and I would explain you that very categorically how to do it. Please understand that very well. Say for example, I'm having an answer as -2 is less than x is less than or equal to 5. And they've told us that x belongs to real numbers. Now, in this case, understand this very well. -2 is the smallest number, so I'll begin with -3. Here 5, so it should end with 6. What I'm representing here is -2, -1, 0, 1, 2, 3, 4, 5 and 6. I told you lollipop method. So what is the smallest number here? -2. So I'll make a lollipop above -2. The biggest number is 5. I'll make lollipop above 5. Now understand this very well. These lollipops will be joined by a horizontal line almost parallel to the number line, and I will shed the interior part of this obtained rectangle kind of shape. Why I have shaded this all? Because real numbers between -2 to -1, there can be infinite numbers. So I have to include all the numbers, hence this is highlighted. One more thing you have to be very careful about it. You see the sign over here, it is less than -2 is less than x. So this lollipop is not, darkened over here. This lollipop I'm darkening over here. Why I'm darkening over here, you have to understand, because it includes 5, right? Here it was not including -2. If here it would have been inclusive of -2, then I would darken this circle also, but right now I'm not darkening that circle because my question or my solution says that -2 is less than x. So 2 lollipops above the numbers, and remember that to darken the region, almost rectangular shape region, you have to do the shading, and either of the circles may be lollipop means maybe darken, or a few times one, and some cases none. Say for example, I am taking another example as -1 is less than x is less than 4. So if I want to make a lollipop in this case, -1, so I'll begin with -2, -1, 0, 1, 2, 3, 4 and one more number 5. -1, I have to make a lollipop over -1. I have to make a lollipop over 4. I have to join top part of the lollipops in a horizontal way. This entire part will be shaded. And now I have to decide whether any of the lollipop or both lollipops will be shaded or not. In this case, none of the lollipop will be shaded because here it is purely less than 1, and here is here -1 is less than x, and here x is less than 4. So I hope this part is pretty clear to you, how to make the lollipops. This happens only in the case of answers are in the form of real numbers. I would take you back to your lower grades. Say x is equal to 5 upon 4, and I want to represent only this number on a number line. Then my dear friends, what we used to do, I will just remind you that, and then we shall go one more concept of answering in real numbers. Say for example, I am having 0 here, then I will have 1, but as the denominator is 4, 0 to 1 will be divided into 4 equal parts, 1, 2, 3. Now when I mark 3 numbers here, it is divided into 4 parts, 1, 2, 3 and 4. This number will represent 1 upon 4, this number will represent 2 upon 4, this number will represent 3 upon 4, this number represents 4 upon 4, which is nothing else but 1. Again from 1 to 2 when I go, I have to divide it into 4 equal parts, 1, 2, 3. If I mark 3 things, then it will be divided into 4 equal parts. What will be this number representing? This number will represent 5 upon 4. This number will represent 6 upon 4, 7 upon 4, 8 upon 4, which is equal to 2. So I have to represent 5 upon 4 over here. So my number over here, x value, is nothing else but represented over here. Why I'm showing you this? Because exactly after this we are going to understand if the answer is in the form of a fraction, then what should you do to represent it on a number line. Say for example, I'm having a solution something like this. Negative 2 is less than or equal to x is less than or equal to 7 over 3. Now I'll draw the number line, and they have mentioned that x belongs to real numbers. I'll draw the number line negative 2, so I will begin with negative 3. You can convert this roughly into, in the rough work, you can convert it into a mixed fraction kind of form. So 3 2s are 6, 2 1 upon 3. So your number is 2, 1 more than 2, that is 3 should be there at the succeeding number. Negative 3, negative 2, negative 1, 0, 1, 2, now, and here 3. Fine. Now your number line last part is given in fraction. So I'll divide between 2 to 3. You need not divide each part. 2 to 3, I'll divide into 3 parts, 1 and 2. If I mark 2 points, then it will be divided into 3 parts. So this is 2, this will be 2 1 upon 3, or this will be 7 upon 3. So your lollipop will start from negative 2, and your lollipop will end over here, which is 7 upon 3. You will join those lollipops. You'll shed the interior part of rectangular thing. You have to decide which of the lollipop will be shedded. And if you understand this very well, negative 2 is less than or equal to, so this lollipop will be shedded, and this won't be shedded over here, right? And remember, here some of you will say, sir, if I write down up to 8 upon 3 will do. No, I have written up to 3. You have to write down the whole number or the integral part as a next number. Not only this will do, you have to write down up to this. This is the representing solution of a inequation on a number line. We have seen for natural numbers, we have seen for whole numbers, we have seen for integers and real numbers. And I would suggest there are various ways of showing the real numbers. I would request you to follow only Lollipop method, which would be easier for you to do it.